Welcome to Utilizing Tech, the podcast from Gestalt IT. This season on Utilizing Tech, we're focusing on CXL, an exciting technology that has the potential to transform the IT industry. I'm your host, Stephen Foskett from Gestalt IT, and joining me today as my co-host is Craig Rodgers.
I am a solutions architect, and I'm very interested to continue learning about CXL.
And also joining us today on this episode, as always, we have a guest from the industry who's actually working to make this technology a reality. MemVerge is a company that you may have heard about on our Tech Field Day events or on Gestalt IT coverage generally. And I'm happy to have Yue Li here from MemVerge joining us for this discussion.
Hi, my name is Yue Li, co-founder CTO of MemVerge. I'm very glad to join the discussions.
So we, as I said, have had MemVerge present at Tech Field Day before. And essentially, MemVerge is, in my understanding, software that enables you to do cool things with memory on servers. Hierarchical or tiered memory, as well as some kind of magical virtualization-y, snapshot-y kind of cool stuff, too. First, let's start off with the current state of affairs with CXL. So as our listeners know, CXL is an emerging technology based on PCI Express that lets servers basically break a lot of the boundaries that we've previously had for systems architecture. But now CXL is not that. Now CXL is something very new. It's just emerging. And the product landscape consists of memory expansion cards from Samsung and SK Hynix, of support coming soon from AMD and Intel's server platforms, and basically software from you, right?
Yes.
So tell us a little bit more, as someone who's working in this space, what's real now in, I guess, memory expansion over CXL?
Well, I think right now CXL just, I think, is still at the starting point. Right now, what we see is that basically CPU providers, vendors, Intel, AMD, they are still sampling the next generation CPUs that provides CXL support. And also from the memory vendors, they are pushing out also early samples, engineering samples for memory expansion cards. And there are also PCIe CXL switch vendors that are also trying to create the early prototype for those. And we're also for us, we're a software company that's trying to work on the next generation memory management software to work together with these hardwares.
So you fit nicely into this world because the first products are of CXL. Now, admittedly, CXL will not be memory forever. It's not just about memory.
Right.
But to start with, it is just about memory. At least that's where the initial products are, and that just happens to be your area.
Yes, I think as a matter of fact, in the early days, CXL was also invented for not only memory, but also for accelerators, such as GPUs and FPGAs also, to allow those processors to communicate with each other using the memories on those on those cards. So that, and I think the memory expansion card is a very natural derivation of those developments. So it actually came later, but it became a very important and interesting use case for CXL.
So Yue Li, tell me more about what your products are actually doing with memory.
Sure. So our product today is called Memory Machine. So Memory Machine basically right now has two major features. The first feature is called memory tiering. So the memory tiering essentially is a software that allows you to pull different kind of memory together. So for example, in the old days, there will be the local DRAM, which is faster, and also the, let's say, Intel Optane persistent memory, which is slower. But in the future, basically will be the DRAM and the other type of memory, such as the CXL memory, that can be placed locally in the chassis or remotely connected through some switches.
So it sounds as though you have already solved a lot of the engineering challenges around that memory tiering that would be applicable whenever CXL is more widely available.
Yes. So as a matter of fact, actually the Intel Optane persistent memory technology is actually helping us to basically shape our product, because what the Optane memory and the CXL are sharing is essentially almost the same software abstractions in the Linux OS. So for example, our software is actually was not designed for Optane, but was designed to work with something called DAX device. The DAX device is what Linux operating system provides to represent a different kind of memory that's different from the DRAM. So in the future, the CXL also will be represented using the DAX device. So if our software works for DAX device, it will naturally work for CXL. And also the CXL memory also will be slightly slower than the DRAM. So in this case, the Intel Optane is actually perhaps a bit much more slower than the DRAM, but you still basically need some algorithm so that you can place the right data in the right tier to balance out the performance. So similar algorithm will apply to CXL, so that helps us to naturally work with CXL well.
So whilst we're all aware of the current roadmap regarding Optane, you actually think it's an improvement to be using CXL-based RAM versus existing Optane?
I think so. So from what we observed, the CXL memory definitely, I think, are providing the DDR-based CXL memory right now are providing much higher throughput and a much lower latency than Intel Optane persistent memory. This is simply because they are using, they are just one of the most important reasons they are using DRAM, not the persistent memory media. And also they are using PCIe Gen 5 and Gen 6, which are providing very large throughput and lower latency as well.
So memory tiering is one aspect of your solution. What other features are MemVerge providing?
Yes. So the other features or the other set of features we provide is called in-memory data services. And one of the such example is we call it in-memory snapshots. So the motivation of that is actually to protect the application that has large memory footprint. Because naturally, if you have a CXL or if you have persistent memory, your memory footprint will definitely grow up. Because if you have to, typically the use case will be big memory applications. Otherwise, you won't need those kind of memory, right? So if your application has large memory footprints, it will be very difficult to protect the data if there's a crash, right? For example, if you think about a big in-memory databases, if there's a crash or if there's a failure, then you have to reload all the data from the persistent storage back to the memory to recover the state, which takes a very long time. So what we offer essentially is an in-memory data snapshot technology, just like those snapshot technology used for protecting storage systems, where we can take a snapshot of the in-memory states of those big memory applications, and also this snapshot can help to recover them instantaneously without using the slow storage.
I've seen some things online there around your technology and how your customers leveraging that capability. I've seen some things around AWS and spot instances. Mm-hmm. How are your customers using your technology then, and what advantages?
So on the cloud, basically we have an interesting use case with spot instance. So the spot instance basically is one kind of a VM instance provided by most of the cloud vendors to help you to reduce the cost. So it's very cheap to use, and also your user can enjoy the same kind of configurations they want from the on-demand instance. But there's always a trade-off. The trade-off is that the cloud vendor can reclaim the resource anytime and just give you, from 30 seconds to 2 minutes to react on that. So if they reclaim the resources, then basically everything you are running will be gone immediately. So what we provide is we have an in-memory snapshot capability. So we build up a management software that basically helps user to run their workload on spot instance. And meanwhile, we start taking, for example, periodical snapshots of their in-memory states, and also trying to basically back them up to some shared persistent storage such as S3, so that once the cloud vendor starts reclaiming those instances, we can automatically ship those snapshots to a new spot instance and suddenly recover the workload lost from the previous spot instance in the new instance, so that the workload can continue running without losing the past state. So you don't have to start your compute from the scratch. So as the end user, they basically enjoy that still the same kind of spot instant, the low price, and still can make sure they can transparently make their workload finish on time without introducing too much interruptions.
Sounds like a great new layer of protection.
Yep. And a great capability in the cloud. So getting back to, though, basically how the memory is used. Mm-hmm. So as you mentioned, there are certain similarities, certainly similarities between Optane persistent memory and CXL memory.
Yes.
Especially in terms of how it is presented in Linux and the sort of software that is needed to enable those things. And you happen to have created that software that works with that. How is this memory presented to the application? Does the application see it as different, or does the application just see more memory?
Yes, so that's an interesting question. I think right now, as far as I know, so there are at least two ways or two important ways that the application will see this. So the first way is probably more transparent, which is basically just a very natural memory expansion. So for some kind of CPU vendors, for some CPUs, if you set the BIOS correctly, so those memory will automatically be counted as the system memory. So if you boot up the system, you will see a large piece of memory you can use without doing any system setup. And of course, some of those are from DRAM, and some of those are from the CXL memory. So that's the first one that's most transparent. The second way is actually the CXL will be automatically represented as a device. So if if it's represented by the device, when you boot up the system, you actually won't see the system memory show up, and also all these system memory actually are captured by that device. Then you need some software to basically virtualize the device into the system memory, such as our software, so that you can actually use it transparently. Mm-hmm. And or you might want to use that device for other purposes, such as maybe you can turn it into let's say a shared memory storage system or shared memory file system, right? So in that case, you can also use it for storage applications as well.
Yeah. Yeah, and I think ultimately, do you think the goal of big memory and memory expansion is going to be to have transparent access to a huge pool of memory? Or do you think that applications are going to want to have discrete access to different types of memory?
Yes, I think both will come, but I personally think the first one to transparently access the memory will come first, because you don't expect because it's a new technology, so you don't expect the old applications to significantly get rewritten to leverage those discrete different type of memory devices, right? I know it happened like Oracle or SAP HANA, they modified, but it took lots of effort. So for most of the existing applications, VMware, KVM, containers, they will not be modified. So they will prefer to use the memory transparently first, just to start basically tasting the sweetness of the CXL memory expansion. Then there will be application developers. They say, "Oh, it's so nice, and I think I can do better." So then, in that case, they'll try to ask for APIs and SDKs. Their companies, Samsung and others, they're pushing out the SMDK and others. We have our own development toolkit as well. So in those cases, you can try to best leverage those devices with SDKs to accurately allocate memory and manage the different tier explicitly. And also, this already happened to SAP HANA, as I mentioned, when in the era of the Optane as persistent memory.
Well, it's important that you mention SAP HANA and Oracle and big data applications that have been created to use Optane PMEM. Are those, it sounds like those would be in a good situation to also leverage CXL-based memory because they've already been modified to handle different classes of memory. And this is another different class of memory. But it sounds like, those would be pretty adaptable to this CXL future.
Yes, I think, so in general, yes, I think definitely their existing modification should partially work on the CXL memory. Why do I say it's partially? It is because one of the most important factors they need to change their software for is the persistence. Mm-hmm. So if you look at Intel Optane PMEM, right? So Oracle, SAP HANA, they all actually their new design all actually considers the persistence in their design. So they actually call CPU cache flush instructions to persist the data they wrote into the persistent memory. Now we are entering the CXL memory era, and the persistent memory is no longer there. So they actually need to modify those code, or maybe some of those code can no longer be have the right assumption because the CXL memory no longer is persistent. So they have to maybe turn those back into a cache mode because you cannot hold data there anymore.
And I guess the other aspect is that Optane was bigger and cheaper than DRAM. CXL-based memory, I hate to say it, but is not going to be as big and cheap as Optane promised to be because it's still DRAM and it's still going to cost a lot of money.
Yes.
So I think that, from an architecture standpoint, there's also that aspect of it, that people may have optimized an application or hoped for a bigger pool of persistent memory based on Optane than they will be able to get with CXL.
Yes, yes. I think in the CXL era, because of the use of DRAM, it gets more challenging to reason about the cost, right? So you have to pay for the CXL card. In the future, maybe you have to pay for the CXL switches. And the way to reduce cost is actually will also be different. So for example, but it will be sounds very familiar in the sense that it will be similar to how you reason about storage cost reduction. In this case, imagine that you will be the multiple computer server will share a large memory pool, right? In those cases, you may start introducing things like sync provisioning and others similar to the storage system that basically you pretend that the computer server have large memory to use, but actual memory you have in the box is much less than that. So that's another way to reduce the cost. So, and the other way I think it will come is that, of course, CXL seems like to start with the DDR5 chips, but I think it will naturally start using also DDR4 chips also, which will be cheaper than DDR5. And also, personally, I strongly believe that the persistent memory technology might come back from other vendors in the future, because I do see it's a promising technology, has lots of valid use cases as well.
Yeah, and in fact, I think that some of the companies that are, specifically Samsung, has a flash-based persistent memory offering, yes. and I bet that that's going to be in CXL as well.
Yeah, I think so. Yeah.
It filled a nice gap between NVMe and RAM in terms of performance and latency. It was an order of magnitude better.
And I think that's the thing. We need to talk about the elephant in the room, which is Optane.
Yeah.
So a lot of people are looking at CXL as sort of the replacement for Optane, and that's somewhat true because, as you said, as we've talked about here, it uses similar interfaces and it fills similar gaps and so on. But we've also talked about the fact that they're different. Intel, we know, has ended development of Optane. That doesn't mean that Optane is off the market. And in fact, because CXL really needs the next generation of Intel or AMD CPUs to work, the current generation is very Optane dependent. And in fact, Intel has said that they do, or at least they previously said that they do plan to develop a third generation, the Optane PMEM 300. They're still shipping the 200s. By all accounts, they still have plenty of Optane in the market. So Optane is not quite as dead as people say, but it is a dead end. And CXL is the next wide open road beyond it. That's my opinion. What do you guys think? Actually, Craig, let me ask you, what do you think of Optane's demise?
The announcement was a shock and surprise to many people in the industry. The benefits of Optane were seen and recognized, and I think they will continue to be with persistent memory via CXL. There were a lot of workloads and use cases where they benefited from it. A few of the solutions that you mentioned scale up very well in terms of memory, so CXL is plugging a hole there. I think we have to get the servers out. We need Intel and AMD to get the servers out that'll enable companies like yourselves to have actual kit that you can develop your products further on, add more features and services, and that'll be the same way across the entire industry. It's a logical progression for CXL because we know where it's leading, but even in the near term, there's immediate use cases for being able to add huge quantities of RAM to a single server. So I think it'll succeed initially based on that alone. But in 5-10 years' time, it'll be much more functional, but straight away it's solving a problem.
Anything else to add about Optane?
Yeah, I think a CXL is naturally, you call it the extension. I call it actually it's a natural generalization of the PMEM. So first of all, there is definitely a plan that PMEM is moving to the CXL bus, right? And also you can see that during the development of the PMEM, lots of operating system software, such as DEX device support and the tiering support and all the others, become more and more mature. So all these are basically prepare us well for the CXL. And as a matter of fact, today, if you look at the kernel developers for PMEM, today they all become developers to supporting the CXL. So, and if you look at the end customer, I think also the end customer is basically there is certainly a strong need for big memory. So PMEM is one of the solutions for that, and CXL definitely will continue exist and will get much better to solve this problem in a better way.
Yeah, and just to connect this with the previous seasons of Utilizing Tech, where we focused on AI and ML, it seems to me that machine learning is one area that was moving toward big memory and a promising adopter of big memory. I think that that's still going to happen, and there's actually a lot of interesting use cases around CXL for AI and machine learning. You mentioned before memory pooling. So in the future, CXL will enable a basically shelf of memory to be shared among multiple servers that are sitting, above or below it, with reasonable latency and reasonable performance, throughput. And there will be software like yours that can enable those servers to share that data. So if somebody's working on a machine learning training set, for example, you could do a snapshot halfway through and then deploy that training set to other systems in order to accelerate that. Mm-hmm. You could recover if something happened during training. You could even have a situation where a set of data is actively accessed by multiple systems at the same time and parallelize training, which is pretty exciting as well. So I think that just adding CXL to machine learning actually makes a lot of sense. And I hope that those of our listeners who stuck with us through 3 seasons of Utilizing AI see that Optane actually was a promise, but CXL is actually delivering on a promise of big memory for machine learning applications. And that's exciting, and that's cool and relevant. The other thing that I want to bring home here is kind of turning to the future, where CXL technology goes next. CXL wasn't just developed to enable big memory. CXL was also enabled to develop, to share accelerators and resources. And again, connecting this to Utilizing AI, the most common accelerator that will be shared over CXL is GPU. And so we can see a future where there may be a shelf of memory that's shared among multiple servers. There would probably also be a shelf of GPU accelerators that would be shared dynamically with the servers that need them. That's a very exciting prospect to people with big memory and machine learning applications. Can you help us, Yue, since you are very plugged into the CXL market, give us a reality check. In 6 months, what's going to be really on the market? And I know you can't say necessarily that this is, but what do you see being as product categories that are on the market to utilize CXL?
Yes. So I think most importantly, on the hardware side, I'm really looking forward to CXL switch samples or early sample or early reference implementation that allows you to connect the multiple compute servers with a server chassis where you plug in many CXL memory expander cards or accelerator such as GPU and FPGA. So on those, besides the switches, I'm also looking forward to more maturing CXL memory expansion cards from different vendors with better performance and with all kinds of more different type of media rather than DDR5. And also, I'm looking forward to see the support of CXL from the accelerator vendors such as NVIDIA, AMD's, Intel, their GPUs and FPGAs.
So what do you think, Craig? You've been at OCP Summit. You've been studying the products, the initial products, and what the companies are coming out with. Is this realistic? What do you think is the realistic time frame?
It is realistic. At the summit, we were able to see memory being shared between servers, on engineering samples, not final products. It wouldn't be ASIC backed, it would be FPGA. So obviously not a final product, but fantastic to see that it's doable. It's currently in play. And as with everything else these days, API driven, which is going to give programmers, developers, DevOps, everybody more control over how their workloads are run and the resources available to those workloads. So it'll open up a whole raft of options in how we approach workloads in the future, because we've gained more agility, more capability, and more RAM. Yeah. I was very interested at the summit. It was fantastic to see so many big names all there showing their latest and greatest. We saw Samsung, we saw Marvell, we saw big brands that sell a lot of equipment worldwide were appeared to be heavily invested in CXL technology. So it'll be interesting to see these products coming to market within the next 6 months, hopefully.
Yeah, absolutely. And so at OCP Summit, just to let people know, we worked with MemVerge to host a CXL forum where we spent an entire day with presentations from dozens of companies in this industry, whether they're companies that are developing hardware that will support CXL, or companies that are developing, software that will support it, or, and I think that this is probably for me the most exciting thing, was companies that are using it. So, for example, Uber, hyperscalers, Microsoft, Google, they are also looking at this technology as ways to solve real important business challenges that they have in terms of big memory and flexibility, and they're all committed to this as well. And as Craig points out too, if you look at the CXL Consortium website, if you look at the CXL Forum presenter list, it's hard to see a company that's not in this space. In fact, unlike previous attempts at this technology like Gen Z or CCIX or the rest, CXL has basically every name associated with it. Mm-hmm. And it's exciting to see a technology like that. I mean, Yue, again, you guys are in the midst of this. What do you think are the interesting software business challenges that are going to be solved by some of these companies? I mentioned Uber, for example. What are they doing with CXL?
I think, I don't know what they're working on, but for us, I think one of the most important challenges is to provide a very easy to use management software for CXL memory expansion cards or pooled memory. Because you want to basically, the goal is always trying to serve big memory, to provide the end user a big memory when necessary, right? So the necessary part is most important, is that you have to use software to make the memory show up at the right time when it's needed. And also you have to also carefully return those memory back to the pool when applications are releasing those, right? Being able to schedule the memory to show up between different servers and with, certainly with different, SLA requirement or priority is already a very challenging task. and it has to be easy to use.
I think currently that functionality of returning the memory actually requires a reboot on the server currently. However, it will become hot add, hot remove.
Yes, I'm aware of those. I think Linux kernel developers are busy working on this feature to make it hot pluggable, yes.
Difficult challenge.
And it's going to be fun, though, when we have that. Because that's sort of the road that leads us to this sort of magic wonderland that's still admittedly quite far off of composability, of being able to dynamically reconfigure a server, add accelerators, add memory, add CPU, add storage, add I/O, whatever it is, on the fly, and basically have a server that is the size you need it to be now. And that would, I think, be a wonderful future.
Yes.
So I want to ask one more question at the end here of our guest, and I'm surprising you with this question. I apologize for that. I'll give you a moment to think if you need it. Can you think of take away your experience, take away what's really happening, go a few years into the future. What surprising way could CXL transform the industry, any part of the industry? What surprising side effect will CXL have?
It's a very good question. I actually think about this very frequently because when I have time, I do think about these problems. So one of the things I keep on dreaming about is a completely CXL-based software-defined data center, right? I think CXL itself is actually paradigm changing. Think about this, right? Previously, look at the HPC or enterprise compute. You want to compute the EDA workload. What you do is you submit an EDA job or other intensive compute job to your scheduler. There's a job scheduler, LSF, Slurm, and you have to specify in the job file how many CPUs you want, how many GPU you want, how much memory you want. Then the scheduler will, okay, well, let me wait for a while. Let me try to look for the resource that is available. Okay, now you have it. Now let's run it there. And if there's none, then you have to wait. Sometimes you have to queue for, even for days for this pressure resource to show up. Now, with CXL, all these compute, accelerators, memory, storage now are all basically shareable, and they can all scale independently. So now, if this is the software are all ready, so you will see that now I want to submit a job that requires this number of GPUs, this number of CPUs. What the scheduler will do is, okay, let me call the API of the switch and let me make a virtual server for you. So I will provision, grab 2 GPU from this pool, another 10 gigabyte memory from that pool, and so on and so forth. And we'll create that for you so that you can run this maybe totally in the CXL chassis without involving actually the host CPU at all. So could be a chance where, think about those cards. Today, accelerator could be GPU cards, could be FPGA cards. Think about their cards, or maybe related to computational storage. They're cards that just carries ARM cores. And those are CPUs. And you can use ARM cores on the CXL chassis, and you can put your data in your CXL memory cards in the CXL chassis. So all the compute happens on CXL devices, and there's no longer anything to do with the host CPU. And that's something I think is a bit crazy, but I think it might be coming in the future. And I think it might be a caveat to AMD and Intel.
So you think it's going to be transformative to batch job processing, that approach?
Yes, I think so.
Because now you're adding a whole new dimension to the capabilities.
Not only to those batch jobs, but to all the modern schedulers, such as Kubernetes, Kubernetes scheduler, or other container framework, Singularity, and so on and so forth.
AI modeling, inferring.
Yes,
exactly.
Yes, or even maybe for VMware, the vMotion, right? They can, if they can move the VM to any place, they just create a new virtual server and then move the VMs there.
And it's funny because that sounds kind of amazing and far off, but what you're describing actually is very similar or related to what's currently happening, for example, with DPUs in VMware.
Yes.
And what's been proposed with computational storage.
Yes.
And even the HP machine. All of these things are ideas that I think have been around in the industry for a while, and CXL might make those things possible. So I love this visionary idea, and I hope that it works. I do.
I think all the major clouds are going to move towards that direction.
That's great. Well, thank you so much for joining us for this episode of Utilizing CXL. It's great to have a company that is actually right there making this happen today. Again, this whole podcast, Utilizing Tech, is focused on actually making practical use of this technology, not just dreaming about where it goes. It's fun to dream about where it goes, but in terms of practical use of the technology, memory expanders, next generation AMD and Intel chips, and MemVerge, should work, and that's really using it, and I appreciate that. So thank you so much for joining us. Before we go, where can people connect with you or with MemVerge and learn more about your products?
Well, we have a MemVerge have a linking Facebook pages, and also you can go to our website memverge.com to connect with us.
Craig, anything you want to pitch? What's going on with you?
You can contact me on LinkedIn, Craig Rodgers. I'm at Craig Rodgers MS on Twitter, and my blog is craigrogers.co.uk.
And as for me, you can find me on most social media at Foskett. I also host a weekly IT news show called the Gestalt IT Rundown, as well as a weekly podcast, the On-Premise IT Podcast, where we get folks like me and Craig together to talk about various industry topics. And you can find those in your favorite podcast application. Thank you for listening to Utilizing CXL, part of the Utilizing Tech podcast series. If you enjoyed this discussion, please do share it and give us maybe a rating in your favorite podcast application, because that does help. This podcast was brought to you by Gestalt IT, your home for IT coverage from across the enterprise. For show notes and more episodes, go to utilizingtech.com or find us on Twitter at utilizingtech. Thank you for joining and listening, and we'll see you next week.